Hello, Professor Sargent here with you again. I'm going to take a look at an example of creating a T confidence interval and the effects of changing confidence level and of changing the size of the sample. Here we begin with being told that a simple random sample of size n is drawn from a population that is normally distributed. The sample mean X bar is 113. The sample standard deviation is 10. In part A, we want a 96% confidence interval about mu if the sample size n is 23. Okay, so first of all, we need to find what our t-value is. Since the sample size is 23, then the degrees of freedom that we have is 22. Also, I'm going to open up the table here. Not only do we need to know how many degrees of freedom there are to look for which row we're going to be in, but also we need to know which column we are in. So backing up just a bit, with a 96% confidence level, let's clear that stuff out from a different class. Second quit. Okay, so take from 100, take away the 96, divide that in half, and convert that into from a percent to a decimal. So 100% is equal to 1. That's not changing what I have, but that I had 2%. Now I'm expressing that as a pure decimal, 0.02. Reason for that is the setup in this textbook. We would have the area in the right tail being 0.02. Similarly, because of symmetry, 0.02 in a left-hand tail. And so 0.96 in between, or 96%. So now that we know both that we are talking about 22 degrees of freedom, that's one less than the sample size, and alpha over 2 is 0.02, then let's see here. Don't confuse that with 0.20. 0.02 is right here. That is 1, 2, 3, 4, 5, 6, 7. Sorry. In case I scroll too far and we can't see the top anymore, that is the sixth from the right. Find where that column intersects the column for 22 degrees, the row for 22 degrees of freedom. And that is happening at the 2.183. 2.183. That is our t sub alpha over 2, a critical value. I want to show you another option, which I'm not going to use on this particular question because there's no dash t on the question ID, so they are not expecting the use of technology. But we press second and vars to get into the distributions. Option 3 here, inverse normal. Sorry, option 4, inverse t. Tell it the area you want, 0.02. How many degrees of freedom? There were 22. That was one less than the sample size of 23. And that's going to the left. If we round that, that's going to be negative 2.183. Going to the right is what we found in the table, where the 0.02 column was intersecting the 22 degrees of freedom row. So what do we do with that 2.183? Well, I believe the term is standard error for the standard deviation 10 divided by the square root of the sample size. That gives us our standard error. If we multiply that answer by the t-value, that's our margin of error. And to get our lower bound for our confidence interval, we subtract 113 minus the margin of error. And for the upper bound, add it. Any rounding to do should be saved for the end. So let's see here. The lower bound, they want rounded to one decimal place. So 108.4 and 117.6. See how I've done. 8.4 and 117.6. Okay, let's see here. Notice that X bar is, except for the rounding there, about halfway in between. X bar will always be in the confidence interval that we've built around it. We don't know that mu is in there, but we have a 96% confidence level. Now we're still working with 96% here, but replacing it with a lower sample size of 16. I want you to know that we could have done all of that calculation at once for the lower bound. I was just breaking it down by the order of operations previously. Same result for the lower bound on part A, and the same result for the upper bound in part A. So all I need to do is change that 23 to a 16. Oh, no, something else will change as well. X bar is not changed. S has not changed. I changed the sample size, but the degrees of freedom, that has changed. It's one less than the sample size, so 15. That we should be able to see, find where the 0.02 for the area in the right tail intersects the row for 15 degrees of freedom. And that is at 2.249. Notice that that is higher than what we previously had. To get the same level of confidence, we need to have a larger margin of error. Your lower bound and your upper bound are going to be further away from X bar than in the previous part. So that's going to round to 107.4, and the upper bound switch the subtraction to addition. 118.6. If I were to make a number line and mark these two off, and on that same number line, mark these two off, again, except for possibly an issue with the rounding, 113 should be about halfway in between both of those. But this one, because of the lower sample size, that has spread out the confidence interval. This one is further left than this one is. This one is further right than this one is. All right, so how does decreasing the sample size affect the margin of error? What happened, which then led to the wider confidence interval, is as n gets smaller, so does its square root. Dividing 10 by something smaller gave us something larger for the standard error. Between that and having a larger T sub alpha over 2 critical value that gave us a larger margin of error, and it spread out the confidence interval. So it has increased as the sample size decreased. Now, usually that goes the other direction. We're talking about having a smaller margin of error most of the time. That's the goal of a statistician. So you would increase the sample size to decrease the margin of error. Notice there's only one check on that. Construct a 70% confidence interval. We're back to 23 for the sample size. So I get to look in the same column, the same row, 22 degrees of freedom. But I have a different confidence level. That's 70. So I'm going to take that away from 100 and divide by 2. That's going to give me 15. And of course, that's as a percent. So dividing by 100%, got the same quantity represented, but I've taken 15% and turned it into a pure decimal. So I'm going to be looking at the 0.15 column and the 22 degrees of freedom row. 0.15. That's, besides the DF column, it's the third from the left. So 22 degrees of freedom. Now our critical T value, the T sub alpha over 2, is pretty small, 1.061. Scroll back here to what I did with 23, but replace the previous T sub alpha over 2 with a 1.061 to get our lower bound, and then switch the subtraction to addition to get my upper bound. We want that to one decimal place. So 110.8 and 115.2. Now, before I check that answer, comparing that to part A, when we also had a sample size of 23, a lower confidence level is resulting in a smaller margin of error because we've got a smaller critical T value. T sub alpha over 2 is smaller, so a smaller margin of error, and the confidence interval is not as wide. But that's not good. By the way, how I can show that. So 110.8, that's further in, further to the right than 108.4. And then that 117.6 for the upper bound in part A, when we had that same sample size of 23. This is going to be, our lower bound is going to be further in other words, left of that, 117.6 versus 115.2. And again, this is not the goal of statisticians. We don't want low confidence levels. We want high confidence levels. As the level of confidence decreased, size of the interval decreased because the margin of error decreased. So what we want is both a high level of confidence and a low margin of error. The way that you're going to get that is by having larger samples. We look back at the table here, the larger your sample size, then the larger your degrees of freedom will be, so that whatever your area in the right-hand tail is, and whatever your critical T value is, as you look down any one of these columns, these values are decreasing. And our last part of the question. These sample sizes in A through C are less than 30. Therefore, if we had not been told to begin with that the population was normally distributed, the individual scores in the population are normally distributed, If we were not told that, and we did not have or have strong reason to suspect that either, the sample size is less than 30, then we could not have computed these confidence intervals. Another approach would have been needed if it's even possible, or just plain could not be done. So there we go. All right. Going to try to get to another example here shortly.